And once you're sharing the screen there, I think we can go live. Mo, you have the deck with you, right?
Yeah. Let me just
Yeah.
share my screen. Awesome.
We are live.
Awesome. Okay. Hi, everyone, and welcome to our September meetup. My name is Muhannad. I'm a solutions architect and lead technical trainer at AirAsia, and I will be your host for today. And today we have two new speakers. These two speakers, for the first time, they are joining us. We have Brian, and we have Shardul. He's from AirAsia as well. Brian will talk today about Alexa. And I think we didn't have any talk about Alexa for the past 2 years. So this, I think, the first Alexa talk in our user group. So like Brian was saying, we all know that Alexa is a device and not a person. And we're always trying to make her to be like smarter, more human, so people can feel comfortable to interact with her. Very, very interesting topic. I'm not sure what Brian will talk about, but I'm really, really curious to hear what he has to say. And we have Shardul. Shardul, he's really into DevOps stuff, Kubernetes. You can follow him on LinkedIn. He's very active writing some blog posts. And he will talk today about some of the best practices that you may need to use and follow when you are using Kubernetes on AWS or Elastic Kubernetes Service. Before we get started, just like quick call out. If you are not talking, just please help to mute yourself. And if you have any question, we prefer actually to ask the speaker through your mic. But if you don't have a mic, you can just write your question. And if you have time, we will have like a 10 to 15 minutes networking session at the end of the meetup, just to talk about cloud or anything you guys want to talk about. So I will pass it to you, Brian, from here. You can just share your screen.
Okay. First thing I have to do is I'm going to be talking about Alexa. So, and it's funny, in our house, we say Amanda when we were talking about her. So actually, let me go mute one of the devices.
Right. Take your time.
Yeah, my house is, I have definitely drunk the Kool-Aid. I have devices all over the place. So let me just bring up my slides. Let's go to the beginning. Present.
So how many Alexa do you have, Brian, at your place now?
I think I have 14 of the speakers. We've got a Roomba. Most of the lights are Alexa controlled. And we've recently discovered I can control the TV with Alexa, which is really quite nice. So it's like, okay, here I am. Sorry, just so many windows. Tab. There we go. Share. Present. Okay. Okay, yeah, I can see on the screen that you're seeing my screen. Okay, awesome. Okay, so I run the Boston AWS users group, and we're experimenting with some new branding. And the ducks, for people in the Boston area, the ducks are a special symbol in that in our main park in Boston, there was a story called "Make Way for Ducklings," where some ducks were crossing the street and people, stopped the traffic. And so this is a special symbol for Boston. Which there's no reason you should know that. So some of the obligatory branding. In my day job, I work at a company called Foundation Medicine, and we do cancer genomics. So people who have very late stage cancer and have been told, sorry, you're just going to die. We take a sample of their cancer and we do genetic sequencing on it, find out what the specific mutation is, and then we find the specific drug that will help them. And so we save people's lives, which is really awesome, but it's also, as I say, no pressure. So I work in the cloud, and if there's a problem, with our stuff, people die. So it's very rewarding. It's also kind of stressful. But so on the side, I have this company, Wabi Sabi Software, and Wabi Sabi is a Japanese aesthetic of impermanence and change, which I think is great for software. And I've got certifications. I'm a community hero. I used to work with dolphins in Hawaii. Blah blah blah. Okay. And I'm just going to say, if anyone has questions, please jump in. Interactive is always good. So if you have any questions, dive right in. So I'll give you just some initial background on Alexa, because a lot of people, aren't familiar with it. And I'm pleased to, usually at this point, I'm having to tell the devices that I'm not talking to them. So I'm glad that I finally, for once, remembered to mute them. So basically, when you have an Alexa device, the device is sitting there and it's listening all the time. And people get wigged out about privacy. They say, oh my God, the device is listening. It's like, well, yeah, but if you have a cell phone, you've already given up on people listening to you all the time. But the device is actually just listening for what we call the wake word. And so, that's why in order to talk to a device, you have to say, Alexa, tell me the weather, or Alexa, turn on the TV. So just waiting to hear that wake word. So you speak and you say, Alexa, tell me the weather. Excuse me. And the device hears the wake word, listens for the next few seconds, and then it takes that speech and it sends it up to the Amazon cloud. And there's all kinds of processing that happens here, because all it got was, a sound file. And so it has to do natural language understanding. It has to parse it. It has to figure out the words you're saying. Then it has to take those words and make sense of it. And part of the thing is that people will say all kinds of things. Alexa, how's the weather? Alexa, what's it like outside? Alexa, how's the day? It needs to first understand what the words are, and then it has to turn that into what Alexa calls an intention or an intent. And in all of these cases, in this particular case, Alexa would say, you're asking for the weather, so we'll trigger the weather intent. And then it sends that request. Oh, and then it has to say, okay, so I have this intent. Who should handle it? Because Amazon itself has, thousands of skills ready to handle requests, but then there are literally hundreds of thousands of developers like myself who have written skills that want to handle particular things. So it figures out who the skill should go to. It then sends that request as an intention to your skill. Now, I'm going to be talking about my primary skill, which is called Premier League. In my household, we are crazy fans for British football, soccer. We don't actually say the soccer word in my household. To us, football is the game you play with your feet, and not that National Football League. My son calls the National Football League hand egg ball, and we can't watch it. So my skill is called Premier League, and I've written it in Python. And so basically, when you write a skill, you have an interaction model that you write, and then you have a backend, and my backend is written in Python. And so my Python code gets a request. It figures out what to do with it. It builds a speech fragment, sends it back to the Amazon cloud, which sends it back to your particular device where it says the text. So in my particular case, a user might say, tell me how Arsenal is doing. And it goes through, it figures out, okay, they want to talk to Brian's skill. They're asking about Arsenal. Let's say, say how Arsenal has been doing lately. It comes to, I have an intention that's, called a team intention. I go look up Arsenal. I say they're doing terrible because my son hates Arsenal. Sorry if you're Arsenal fans here. And it comes back, and then it comes back and says, oh, Arsenal, they're doing so bad this year. That's excellent. So that's how the skill works in general. And so you don't notice any of that because you say, how's Arsenal or how's the weather? And you expect a response back, hopefully within a couple hundred milliseconds. So you're unaware that all of this has happened, but it's sort of astonishing how much is actually happening in the background. Any questions on sort of how Alexa works in general? Okay. So we're talking about Alexa emotionality, and there's this thing called the Uncanny Valley. And basically, that's if you make a simulation of a person and you make it almost right, but not quite right, it becomes kind of, it wigs people out. So when there are, videos of artificial intelligence creatures, like in the old video games, everything was just a bunch of pixels, and it was kind of silly. But now video games have gotten so good that it's actually a little hard to tell sometimes if you're looking at a video game or a real TV. In the case of my household, when my son is playing, FIFA 21, the players look pretty amazing. They've got stubble on their face. But there's this notion of it, if it looks too good, but you can still tell that there's something wrong, that can tend to scare people. So we know that Alexa isn't a person, but we refer to Alexa as she, because the default voice is female. Now, Amazon has recently rolled out that you can change the default voice to be a male voice. And I changed one of our Alexa devices to be a male voice in my household, and the rest of my family was totally wigged out. They're like, no, that's not Alexa. That's too weird. So we know that Alexa is just a bunch of software and not a person, but we work really hard to not put that in your face. We want you to be able to interact with Alexa as if it was a person. So like one of the things, Alexa now does what they call follow-up mode. So you'll make a request to Alexa, she will respond. And a lot of people then would say, thank you, and got bugged that Alexa wasn't listening. So now I can say, Alexa, turn on the lights, and it turns on the lights, and I say, thank you. And Alexa will say, no problem. And it is funny because we have a dog and who sleeps on our bed. And recently my wife said, Alexa, turn down the lights, and the lights turned down. And then she said to the dog, you can jump up now. And Alexa said, no, I really can't do that. It's like, no, we weren't talking to you. So one of the things is we want Alexa to not talk so much like a computer. I mean, I don't know if you have, where your telephone system is at in Malaysia, but if you call a bank, the bank and try to do something over the phone, the bank response probably will be, press 1 for checking, press 2 for savings, press 3 to get a balance. And it's always going to be the same, and it's always going to sound flat like that. And in fact, some people, these corporate systems try to make that happen so that it's very clear that you're talking to a computer. But people don't talk like that. You can hear in my own voice, I speed up, I slow down, I get excited, and I get unexcited. And so we try to make Alexa have those characteristics, because then it feels more natural and people are more likely to interact with your skill. And I'll say, as a skill writer, we sort of live and breathe for people interacting with our skill as much as possible. So I'm going to play you some stuff, and you can hear the differences. And let's see if we can get this going.
This is a simple spoken response.
And can someone confirm that you heard that?
Yeah, very clear.
Yes, we did.
Okay, great. Okay, excellent. Okay, so I'm just gonna play it again. It's like, or am I gonna play it again? There we go.
This is a simple spoken response.
That's what Alexa usually sounds like, and it's fine. It's okay, but that by itself, if you just hear that over and over again, you're never going to be puzzled whether you're talking to a person or not. Okay. So now and I'll show you what this code, let me go back and show you the code. So this is actually the code you would use to do that. So we have a function handle, which, handles what happens. And there's a function called handler input, which is the input to handler. And you can see that, unlike very, very simple code, you can probably read that. The handle function is going to handle the handler input, and it's going to return a speak. And so it's going to speak this text, okay? And the ask is just if it doesn't hear anything and it wants, more of a response. So now this code is a little bit different. So here we have speech text, and down here we're returning the speak of speech text. So let's look at speech text. So this is a string, but you can see it's a string with some interesting bits in between. And these interesting bits between the angle brackets are called SSML, Speech Synthesis Markup Language. Sorry, it's early in the morning for me. I've only had one cup of coffee, so bleh. So what this is saying is we want to use an Amazon emotion. The name of that emotion is excited, and it's a high level of excitement. And then we turn excitement off. So let's play that.
This is a simple spoken response with emotion indicators. Liverpool wins the league, and so on and so on. Emotions take time.
So a couple things. You probably noticed that although the emotion indicator started here, it wasn't until it got to about here that the excitement really kicked in. At first, I thought that was a bug, but I think that's actually a clever thing in that you don't go from a simple dead stop. Humans have a little ramp to their emotion. And so does Alexa. So I can say, I made this sentence be longer and so on to show you, excuse me, that the emotionality will kick in after a bit. But you can see it's really, the sound, I think, is much better.
This is a simple spoken response with emotion indicators. Liverpool wins the league, and so on and so on. Emotions take time.
So that's, that is exciting. And it's really pretty simple. You just say, hey, I've got this emotion, and speak it with that inflection. So it's pretty simple, actually, to do that. And so that's one of the ways that we can add variety. So here I'm showing that we have you can also speak in different voices. So this is going to say the same phrase, but with different voicing.
This is a simple spoken response.
This is a simple spoken response. This is a simple spoken response.
This is a simple spoken response.
This is a simple spoken response. This is a simple spoken response.
This is a simple spoken response.
So you can see that those were, you can hear that those were all very different. You can probably guess that Nicole was Australian. I think Hans was German. So you can add a lot of variety. Now, it's actually kind of interesting in that Amazon both wants there to be lots of variety, but also wants there to be a common user experience for anyone using their devices. So they give you a choice of different voicing, but in general, you don't make up your own voice. Now you can, but that's sort of an advanced topic. So just like spices, use these effects sparingly. If you dumped a ton of salt on your food, it wouldn't be very good. But if you put a little salt, a little cayenne, it's nice. But use it sparingly.
The best team in the league is Leicester. The worst team in the league is Arsenal.
So you can see that, and clearly I'm biased, but it's Leicester is good and Arsenal is bad. So you don't want to overdo that. If you, if I was speaking really excited and really slow, and then more excited, and then it would get tiresome. And I hope it already hasn't. So you can use these things, but use them, a bit at a time. And so that gets us to this whole notion of variety, in that most computer interaction systems, if you give them the same input, they'll give you the same output over and over and over again. Most systems, if you say, what's the weather? And then say again, what's the weather? And it's again, say, what's the weather? It'll say it to you in very much the same way. There are simple tricks that you can use, and I'm frankly shocked that more skilled writers don't do this, in that every time I say something to the user, I have an array of possible ways to say it, and I randomize which one I'm going to say. So if someone asks me who scored the most, you can see on the slide, I don't necessarily need to read it. You can see that there are 3 different ways I can tell you who has the most goals. And it's a simple thing, and most people don't even really notice it at first. If you ask most people who play with my skill, is it telling you the same thing every time? Most people will say, yeah, it is, but it's really not. It's varying what it says, and that makes it seem just a little less computery. But it's also kind of tricky because it can get into language idioms. So right now I'm making a Spanish version of the skill, and I'm finding that some of the things don't really translate. So in British soccer, if you're talking about the upcoming games, we refer to them as fixtures. But when I tried to translate that into Spanish, it said something about plumbing. And in British soccer, if you get a yellow card, we say that you've been booked. And the Spanish version translated that as the players who've been booked the most got translated as the players who have the most reservations, like it was a reservation, an airline reservation, an airline booking. So you have to be a little careful with that. But you want to, so again, if you're doing multi-language, you have to be careful with that, but you want to use variety. And I can show you here that it's really quite simple. I mean, it's not, it's almost as dead simple as it gets. So every time you ask my skill a question and it gives the answer back, my skill then asks you what you want to do next. And so I just have an array of various prompts. I can say, what can we tell you about Premier League? Or, you can ask about the team, or you can ask about the team or the table. And so I have a variety of prompts, and then I literally just randomize which prompts I'm going to do. Now, suggestions are another whole thing, in that my skill has about 12 or 15 different, what I call verbs that you can ask. You know, if you're some skills, like if you're asking about the weather, you say, how's the weather? But you also might say, you know, is it raining? Is it snowing? And so on. In my skill, you can say, you know, ask about a team. You can say, ask about touches or tackles or fouls or referees or stadiums. Now, the question is, how do I tell the user that there are all these choices if I have no visual screen? Because even though Alexa has some visual devices, most devices are just sound. Now, if you were doing a standard visual input, you'd have, you know, a drop-down list or a combo box list. And people would just pick from there, and it would be obvious that there were lots of choices. But how do you tell choices when it's voice only? This is a real problem. In the early days, there were skills that would say, you can do A, or you can do B, or you can do C, or you can do M. And of course, you know, by then you've given up and you don't remember the choices anyway. So I have a list of suggestions in my skill that say, you can also ask about touches. You can also ask about fouls. And I randomize the suggestions here. So I give you a randomized prompt and then a randomized suggestion. And once I've made the suggestion to you, I take it out of the suggestion list so I don't ask you again. So the system gradually teaches you how to use it. So it's, you know, a few lines of code can make a world of difference in how the system sounds to the user. So now I decided, well, I want to make this system sound more like it would sound at an actual football match. And if you've ever been to, well, I mean, at any sporting event, there's all kinds of crowd noise. In British football, the crowd gets very, very agitated, we'll say. And so I wanted a way to have there be background crowd noise. And so in this case, I had to do something a little bit differently. So I still have the person talking to the device, going up to the cloud, and it goes out to my Lambda function. But now, instead of just speaking, I render a document, and I'll show you that in a sec. And that document tells the system how to mix together text and an audio file. So the document has a language that you write in, and then it has data that you pass, so you can bind the data to the thing. And I will say the documentation for this is really quite bad, and so it's best to start with a working example. I will say on my webpage, briantarbox.org, I've got a link to some working examples that are videos and the code itself. So I'm going to show you how to do this, but let's see if we can play this.
The highest scorers are Bruno Fernandes, with Manchester United has 3, like Alien, with Leeds United has 1, Sergio Canos, with Brentford has 1, Christian Norgard, with Brentford has 1.
So it's a little hard to hear in that example, but there's some crowd noise in the background. And one of the things that I've done, again, for randomness is I have a long sound file of crowd noise, but the system always starts at a random place in there. So you can ask the same question multiple times and you'll have different background crowd noise. So this is now the code that you use to do this background crowd noise. And that again, we have the handler input, but this time, instead of doing a speak, we're doing this add directive. And we have the Alexa presentation language audio render document. And we have this document, and I'll show you how to create this in a sec. And you know, this is the pointer to the source. So let me show you that. So this is the beginning part of the document. It's just a JSON file, and there's actually an editor that will create this for you, so you don't have to write all this yourself. And there's this notion of a sequence, so you can play one bit of sound, the next bit of sound, and the next bit of sound. And here you can see that I have a sequence of items, and here I've got the text that I want to speak, and here is some crowd noise. And one of the things that I wondered at the beginning was, since this speech is going to be different lengths, how do I adjust this crowd noise so that it only has crowd noise while it's speaking? And there's this notion of trim to parent, so you can only play this while this is going. And this is just to show you that there is an editor, and you can see here, the system will create most of this for you. You have here the data that you're going to pass in, the actual language, and then I circle these because it's not apparent if you first start playing with this, but this is how you save things, and you can download them and play them yourself, but you can also just, if you save it, then it becomes available to the system. The sort of last thing I want to talk to you about is that speech really matters when you change languages. So I mentioned that I'm doing a Spanish version of my skill, and there's the actual translation, and that's one bit of the change, but there's also how you make it sound reasonable. And my first attempts were horrible, and so I'm going to play this for you, and you're supposed to cringe because it's supposed to be horrible.
The winner of the Premier League might be Liverpool, or it could be Chelsea.
So that's just straight English. So now I'm going to have Alexa's straight English try to say that speaking the Spanish equivalent, and it's pretty awful.
El ganador de la Premier League podría ser el Liverpool o podría ser el Chelsea.
So that's really awful.
Sounds good to me, but because maybe we don't speak Spanish.
Oh, okay. Well, you'll see the difference in the next two. So this next one is, I've just told it the language is Spanish.
El ganador de la Premier League podría ser el Liverpool o podría ser el Chelsea.
So that didn't really change things or improve it. So saying that it's a Spanish language doesn't help. But now I say, but I really want Miguel to be the one speaking it. So now you'll hear very much difference.
El ganador de la Premier League podría ser el Liverpool o podría ser el Chelsea.
Wow, that now I can hear the difference.
Yeah. So that's really important. So it's my wife speaks Spanish, and when I played her the first version, she literally cringed. It's like, you can't do that. That's terrible. But when you get the end of, blah, 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 and I don't speak Spanish, so I can't do it, but, it's the rolling of the R's and so on. So there's if you take away nothing else from this talk, take away this, that it is possible, you can very easily write a simple skill that speaks in a monotone and answers, the particular question. But if you take a little bit more time, you can do sort of amazing things, and you can make the system seem much more interesting. I will say, when I was first writing the skill, I was getting maybe 300 users in a month. And that seemed fine. That's, 300 is more than zero. But recently, as I've added all the voice stuff, and I've also added support for the screen devices, what's called engagement with the skill has gone through the roof. So in this last month, I've had 90,000 interactions with my skill. So up from 300 to 90,000, simply by making the voice seem a little bit nicer. And people sometimes ask, Brian, why do you do this? Because you've put a lot of time and effort into the skill. And originally I did it just because I wanted to know the information that my skill would provide, but now it's sort of become a game. And I will say that we don't charge people for the skills, but Amazon decides every month which skills had what they call the most engagement, and they send us a little money. So when my skill started to, I didn't get any money from Amazon for the first 2 or 3 years, and then one day I got a check for $30, and it's like, okay, I put thousands of hours into this skill and I got $30 back. Well, okay, 30 is more than 0. But now as the traffic has taken off, I'm actually making, again, small money, but anytime Amazon sends me money instead of me sending them money, I consider that a victory. So I think that is the end. I think that's the last slide. So any questions?
Great. So you guys can just unmute yourself if you have any question and ask directly to Brian. Okay, Brian, you have one question on the chat from David.
Okay.
He's saying, any cost to host the skill on AWS?
Okay, great. That's a great question. So Amazon does not charge you anything for the skill itself. Now, if you use, so like the back end of my skill is Lambda, and I could be charged for Lambda, but one of the really nice things about Lambda is Amazon gives you the first 1 million invocations a month for free. So I have never paid a penny for Alexa. Now, if you use other Amazon services, you can get a charge for that. But one of the nice things is that Amazon also sends me a $100 credit, $100 US credit a month to compensate me for providing this skill. And so I've never paid a penny. And part of the notion is that by writing skills, we make Alexa more interesting. And so Amazon sells more Alexa devices. So they really want us to do things. So it shouldn't cost you anything at all.
So Brian, from a hosting perspective, you're using just Lambda or anything else from the overall architecture wise?
Sure. Well, in addition to Lambda, I use S3. So I store my data files on S3. The information that talks about what the actual the team results are and so on. I also use CloudWatch for logging and also for looking at metrics. And I also use CloudFront. CloudFront basically lets the system cache copies of web pages and audio responses as well at various places around the world. So my Alexa skill is available any place that there's English. And so interestingly, even though it's British soccer, only about 10% of my users are in England. Most of them are in the US. I have a few in Australia, a few in Canada, and a few in India. So those folks are getting faster results because I'm using CloudFront. I'm hoping by doing Spanish, I can get more engagement in some of the Spanish-speaking countries. I've sort of been surprised how hard it is actually to do the translation. I'd love to get as many languages as possible, but it's non-trivial. But so that's it. Lambda, CloudWatch, S3, CloudFront. But you can do you can do it all just in Lambda if you like.
Right.
Awesome. More questions. Let's see. We have one from Nurul. She's saying, how hard to learn AWS with zero knowledge? So are you talking about AWS Alexa or AWS in general? If Alexa, maybe Brian can tell us like how people can start learning about Alexa skills.
Okay, sure. So I'll say I've been doing Amazon for about 9 years, and I've got a bunch of certifications, and I'm what Amazon calls a community hero because I talk so much. And I'm always learning. So there's, you're always going to be on somewhere on the learning journey with Amazon, because Amazon has hundreds and hundreds of services, but you don't need to know them all. Now, for Alexa itself, it actually can be quite straightforward because Amazon has tried to really lower the bar. So basically, you have to create a developer account. and then you can use blueprints. So Amazon provides example skills. So one of the very, very common skills is a fact skill. So they give you a ready-made skill for facts about what the planets are. And the idea is that you can take that, instantiate it, and now you have a skill, and then you can change it to do different facts that you might care about. And so they really try to make it as gentle as possible to start playing with the system. And if you don't know, they can also take care of hosting the Lambda for you. And you don't have to write in Python. I happen to like Python, but you can use pretty much any computer language that you like at this point.
Awesome. And Rule, if your question is about like AWS in general, so AWS have like multiple certificates. So you can start with one called AWS for Practitioner. What's called? It's new, right? The latest one, I think this one is like for
Cloud Certified Practitioner. Yeah.
Correct. So you can read a bit about it, and I think this one is like for entry level, so like what services provided from AWS and see yourself if you like it or not. I will paste the link for that certificate in the chat. You can read more about it, or you can as well ask us on the Facebook group, and the guys will be happy to guide you where you can start as well.
And I'll say meetups are a great place to learn more about it. Come to the meetups, and you'll be exposed to bunches of different things in the AWS world.
Right, here you go. I hope that answer your question. Okay, there's a law. Do we have one more? Okay, we have one more for those who have already been using Alexa or Lex. Any tips, tricks on how to make smoother conversation with well-designed intents and samples?
Yes. Okay. That's a great question. And it's funny. Conversation is a particular thing in the Alexa world, in that in my skills, I'm at the user is asking one question. How did Arsenal do? Which referees give the most red cards? And those in those skills, it's a sort of one-to-one interaction. And I'll get to the opposite in just a sec. But one of the things you can do is you can give lots of when you create the voice model, you can create lots of different examples. So, I've said if you're going to ask about referees, you can say which referees give the most red cards, or you can say which referees give the most cards, or you can say which referees are the strictest, or which referees are the harshest. So you can give lots of different examples, and you can say, if the user says any of these things or anything like these, then call my skills. So give lots of examples. You can also do synonyms. So Arsenal's nickname is the Gunners. So my system is set up so you can say, how is Arsenal doing? But you can also say, tell me about the Gunners. And so you can have synonyms, and that's very helpful in how people speak. Now, you also have conversational interaction. So one of the usual examples is the pizza ordering service. You say, I want to order a pizza. Well, what size pizza? I want a large pizza. Okay, you want a large pizza. What would you like on it? I'd like pepperoni. Would you like anything else? Yes, I'd like onions. When would you like that delivered? I'd like that delivered soon. That's the sort of interaction you would have with a real pizza place. Amazon has these things called conversations, where you can say, here are all the things I need. I need to know the size. I need to know the toppings. I need to know when. But the user could say them in any order. And so Amazon has this whole thing of conversation design, which is actually fairly straightforward to do. You basically mark slots as required or optional, and then Amazon will actually take care of figuring out what information you've already gathered and what's still to be done. And that's called an Alexa conversation. So if you're asking the user for multiple things, I'd really recommend looking at conversation design.
Awesome. Hope that answer your question. I think that's it for Brian. We asked him a lot of questions. So thank you so much, Brian. And do visit his website. I think, Brian, you can just I think Faz just pasted a link for your website. Go, guys, visit it. And you can follow Brian on LinkedIn as well if you have any future question. I hope he
Yeah,
will
I'm
answer
happy.
you.
I'm happy to accept LinkedIn in connections. And I'd also say, come join our user group. So we actually have a meeting tonight, which will it'll be 5:30 in the morning for you. So maybe watch the recordings.
If you guys are motivated to learn more, you can just join at night and just take off tomorrow. Awesome. Thank you so much, Brian. And hopefully we will get you again in our user group.
Happy to chat. Thank you. Appreciate it.
Great. So before we go to our next speaker, for today, we don't have any hiring announcement, but if you company is hiring or your team is hiring, you can just put it on the chat and let people contact you. If you want us to do like a shout out next meetup, just scan this QR code, tell us what you guys are hiring, and we will share it with the group and on Facebook as well. So I will leave it just for a few minutes for people who's hiring. This is the best place to hunt some good talents. And
if I could actually, while that's up, if you want to try the skills that I talked about, if you go to my webpage, there's a link there that will just go try it. And if you love it, leave me an Amazon review, because that would be amazing. And if you don't love it, send me an email, because I want to hear what I could do better. But anyway, carry on. Sorry.
Awesome. Where's the link, Brian? You can just paste it here so people can access directly and check it out.
Okay. Let me just grab it.
And again, guys, so this is our community, as you know. So if you want to give any talk, it's not necessary to be advanced topic. As you saw here, we have all level people who just start learning about AWS and people who've been working with AWS for years. So any topic, any side project you are working on AWS, come and share it with the community. Do just scan this QR code, fill up your information, and we'll reach out to you through email and to discuss when you are ready. So I will just leave it. And I'm so happy, actually, lately, Kaushik was helping us to get some new people and faces to our user group. So this is your chance to show us your skills on AWS. Awesome. Next speaker, Shardul. Shardul is an engineering manager with AirAsia. Again, like I mentioned at the beginning, he's very active on LinkedIn lately with very cool blog posts about DevOps in general. Today, he will talk about Kubernetes on AWS and the best practices you need to follow when you are using Kubernetes with IAM, Identity and Access Management. So I will leave it to you from here, Shardul. You can just share your screen.
Thank you. Start sharing. Okay. Hello, everyone. My name is Shardul. I'm currently working with AirAsia as an engineering manager. I'm quite involved in AWS. I've been working on AWS for quite a long time now, and I'm also an AWS community builder. So this talk is all about EKS. Okay, just disclaimer before I present this. So here I'm only going to cover one particular best practice, since if I just show it, it will be just very small. So I'm going to go into the details about it, like, what's it about and why should you do that. Okay. Okay. When it comes to EKS, right? We talk about IAM permissions. IAM permissions are actually needed in EKS cluster for the nodes. So nodes are the places, is the actual thing where your worker pods, your pods are running, your workload runs, right? And in EKS, since it's a managed Kubernetes, the control plane remains in the control of AWS, and it is not very much visible to you. You can just see the worker nodes, but and the pods that you are running on them, but nothing from the control plane side. That is all transparent to you. So in this talk, I'm going to talk about the node IAM permissions. There's also one more thing in when it comes to IAM, that is the user IAM permission. So just like node who may require which may require the IAM permissions when it comes to accessing any AWS services such as S3, CloudWatch, even invoking an Lambda function, right? Similarly, a user may also want to connect to EKS cluster and run some commands. So IAM permissions are also required there, but that is a different topic I'm not going to cover here. But basically, that's where Kubernetes RBAC comes into picture. And when it comes to EKS, unlike GKE, EKS leaves everything to RBAC. It doesn't for you to access a cluster. IAM permissions are only applicable as long as you have you have the basic access to get the details of the cluster. That's it. Everything else from that point onwards, it's always the Kubernetes inbuilt RBAC. Okay. So when it comes to node IAM permissions, right? Here the examples that I'm going to show are actually on the EKS control. EKS Retail is one of the utilities which is actually maintained by Weaveworks, and this is what you use to sort of manage and create, bootstrap, or delete your cluster. And so a lot of people use Terraform. So for the sake of simplicity, I'm giving the examples from EKS control because it's all about the concept. You could implement it anywhere, whether you're using Terraform to bootstrap or manage your cluster, or you are using EKS Retail. So in EKS cluster, whenever you create an EKS cluster, you have to provision some sort of worker nodes. So it could be managed node group, or self-managed node group, or even a Fargate profile. So when it comes to managed node groups or self-managed node groups, you can give the permissions to the node groups. Again, the permissions, I'm talking about permissions because let's say you are running a CI/CD pod on the node, on the cluster as a pod, as let's say Jenkins, right? So whenever you're running a job on Jenkins, and let's say you are deploying a cloud formation from there. So on your Jenkins pod, you should have the permissions of CloudFormation. Otherwise, your deployment would fail, right? Your build, for example, let's say you are pushing the images to ECR registry from your Jenkins pod that you're running on EKS cluster, right? So then it will not be able to connect, or even it will not have the enough permissions to send the images to the ECR registry, and that is where these permissions come into picture. So if you want to run those cloud formations as part of a Jenkins, I'm talking about Jenkins because that is where the most of the permissions are used, but there could be an example. Let's say you have an application which interacts with S3 to get some model data, or some sort of static data as well. So that is where you're going to need the S3 permissions. So how do you attach these permissions to the node group in a EKS cluster? So that's where you use this attach policy ARNs. It's under the IAM attribute. So, okay, one thing that we have to note here is whenever you are creating a node group and you're attaching IAM permissions on that, there are 3 sets of IAM permission that you always have to add. If you are not adding them, your node will not be able to connect or register to the EKS cluster. So these 3 policies, I'm going to explain what are they being used for. So whenever you create an EKS cluster, there are 2 or 3 components which are running always. One is kubeproxy. So the more the number of nodes that you have, there will be a daemon set that will be running on your cluster called kubeproxy. Then you will have a core DNS deployment. Core DNS is something that is used for cluster local DNS. And then there's another thing called VPC Cni Plug-In. So this is sort of something which allocates the the CNI, which works as a CNI for your cluster. And this Cni plugin needs a lot of things, needs some permissions, and that is something you define, you give by giving this EKS Cni policy as a managed policy. These are the policies that are managed by the AWS. Then one more thing, all of these workloads, right, that comes default with your cluster, because that they are needed for your cluster to run properly, right? So all of these pods have an image, and all the images are in the ECR registry. And so to get those images, you also need the read-only permissions to the ECR registry. So that's where this ECR Amazon EC2 container registry comes into picture. Apart from that, what happens is whenever a node comes up as part of your node group, be it a managed node group or self-managed node group, your node has to register itself with the cluster. And that is where it requires some sort of permissions, which is necessary for it to keep, give the heartbeat to the so the queue proxy which is running inside of it can give the heartbeat, and even query the control plane as to whether it's healthy or not. So these are the essential permissions that you have to give. Okay, one more thing, the reason that you have to give these permissions is because we are using attach policy errands. If you just want to create a cluster with a node group where you do not want to give any other permissions, you can as well just remove this attach IAM altogether. So by default, automatically when the EKS CTL will create the IAM role for this managed node group, it will automatically add these permissions. But if you are adding some extra permissions, then you have to define them as a mandatory. If you do not do that, your node will always be in the not ready status. So you can query the status of your nodes by running a command kube control get nodes, and there you will see the status as not ready. So if you have this problem, probably these permissions are missing. That is why it is not able to register itself with the control plane. Now, attach policy errand allows you to define permissions. So apart from the default permissions which are required for the node to work properly, what you're doing is you are giving some extra access that will be required for the workload that you're running. Let's say an application which requires you to create, delete, or update the objects or the bucket permissions. So that is where you can define the IAM permissions in the attach policy errand. This is one of the ways to do it. Also, if you do not want to, everywhere you do not want to add these things, you might as well create a role as well. So we can attach the IAM permissions using IAM role also. So instead of adding permissions to each and every node group using attach policy ARN, you might as well create a IAM role, and then you can define its again. If you're adding a role to EC2, then you will also have the instance profile. So you have to give the ARN of the instance profile and the role that you have created, where you have selected as the entity as EC2. There's something to note here. So even though in the earlier attach policy ARN, you are able to define the permissions, but you have to give those 3 extra permissions that are required for the node to run. You have to do that here as well. So let's say you are creating an IAM role and attaching the policies there. You have to add those 3 policies in here as well. And then only your cluster will work. Okay. Now, so these are the 2 ways that you can define IAM permissions for your workloads into your EKS cluster. Okay, but this doesn't always work out. There's a problem with this approach. Problem is that, let's say you're running an S3 an application which requires S3 permissions. Okay, and then let's say you are running a Jenkins on the same node group, right? So essentially, when you bootstrap the cluster and you gave those permissions in using attach policy ARN or using the role, all the nodes essentially will have a role attached which has all those permissions. So regardless whether you are running Jenkins there or your application which requires S3, the application which requires S3 permissions will have all the permissions that you have added for Jenkins, such as CloudFormation I mean, always it's always the use case that you add a lot of admin sort of permissions into your CI/CD pipeline, because you have to your CloudFormation would require a role which has wide variety of admin permissions. And now your application which only needs S3, you have got access, all sort of access. Now that is one of the problems. Okay. Second thing is, one thing that is very important when it comes to EKS or even AWS as a general, that it violates the principle of least privilege. You should always give the permissions that are required for that workload to run. Now, with this approach, it is very hard to do that. Okay, one workaround that I can think of would be creating separate node groups for each and everything. Let's say, so what you would do is you will create a separate one node group called S3, my application node group, where you will attach S3 permissions, and then you would create another node group where you attach all those admin sort of permissions. Now, this could be done, but it is not sustainable, because Kubernetes cluster or EKS is by definition they are multi-tenant. So it is not something that, it's not like a VM. It is, you are supposed to deploy multi-tenant applications there. So many applications could be deployed there, and each and every application would have different sort of requirements when it comes to AWS IAM permissions, and it is actually not feasible for you to create those node groups uh, for each and every application. So you will end up like 20-25 node groups. Now you could still do that, but the problem is, whenever your cluster comes up, it comes up with a node. Now if you're running just an application which requires small amount of memory, for that you're spinning up the entire node group. Node group will have just one node, but still the rest of the resources are going are being wasted. So that is not a good approach. So that is where AWS has provided us a solution which actually helps us to avoid these sort of situations. It's called IAM role for service accounts. It's the short form is IRSA. It is not very new, but I think 1 or 2 years back they introduced this. So what is this IRSA? So IRSA is actually based on the Kubernetes way of giving permissions. A lot of you might know that in Kubernetes, if you want to, so Kubernetes itself has a wide range of permissions inside of the cluster, right? Like accessing, get the node, get the pod, get the deployments, list the pod, list the deployments, a wide variety of get, list, delete, watch resources, right? Get, list, watch are the verbs. So in that you can create a cluster role or role, then you can create a cluster role binding, and then you can attach that as a to the service account, and then you can attach that service account to a pod, which will, now when the pod runs, it will have, if you run kube control get pods, delete pods, it will have all those permissions. Without that, it will not have. So service accounts are Kubernetes native way of managing permissions. So AWS just adds on to that. What it says is that whenever you want to do something, like providing the permissions to a workload, all you have to do is add an annotation to a service account. So you have to create a service account. I mean, in Kubernetes, you can just do like kube control, create SA and the name of service account. But again, service account are namespace specific. So you have to create it in a particular namespace by giving /n as the command. So what AWS says is that you can attach a role to a service account, and the rest of it, we can just take care of it. Let's see how it looks like. Okay, before we look into that, I think one thing that I missed was this IRSA actually works on two things. One is called assume role with web API. I'm sure a lot of you have heard of assume role with identity something API, and then there's OpenID Connect. So this assume role with web API is actually new addition. I think not very new, around 1.5 years back, when it made its way to all the AWS SDKs. Prior to that, it was not available. So one disclaimer here: if you want to use IRSA, and so if you are using AWS SDK such as Python Boto SDK to access AWS services, then you have to have a particular SDK version which supports this. So nowadays, if you are following the AWS SDK version, I'm sure they will have the version, but there's a document online wherein you can find the minimum supported SDK version for assume role with a web API. Apart from that, this IRSS uses OpenID Connect. So OpenID Connect allows you to authorize applications, like different domain altogether, and you can use OpenID Connect for that if you want to use the authentication. So it's actually very simple. What you have to do is, first step, you have to enable the OIDC provider in your EKS cluster. Okay, by default it doesn't have this enabled, so you have to say I am OIDC true. There's a particular configuration that you can use to enable this if you're using EKS CTL to bootstrap your cluster. Okay, second thing is that you can just use an annotation. So let's say you create an IAM role wherein you have added all the permission that you want for this application to use, or maybe Jenkins, wherein you add all those admin sort of permissions. So all you have to do is to take the ARN of the role that you have created and then add it to the eks.amazonaws.com/role ARN as the annotation. And this is how you do it. Okay, so the moment you do that, and if you have OIDC enabled, if you run the command like AWS STS get caller identity, you will be able to get the role assume role for that assume role ARN for that role, and your cluster will have all those. Your pod, if you are using the latest version of AWS CLI or SDK, you will be able to access access all those permissions that you have given to that IAM role. So this is very neat way of defining permissions. Earlier, what we used to do is, like, if we are if we have multiple applications, all of those permissions get mingled, and you might not know when a particular application misbehave, and you end up with a lot of bad things, right? And even let's say your pod gets compromised, and then if you're running your Jenkins and everything on the same notebook, you end up with the total catastrophe. So it would be really problematic then. So this, with IRSA, you don't have to worry about that. All you have to do is to just add an annotation to a service account, and then add this service account to the deployment. Or if you're running a static pod independently, then you can add it to the pod itself. So usually you define it in the deployment spec as a service account name inside of the pod template. Okay, so now let's see how it actually works. The magic, what happens, how it actually works, that suddenly out of nowhere we just took the IAM role and we added it as an annotation, and suddenly our pod started getting those permissions. How does it even work, right? So that is where a particular Kubernetes concept comes into picture. It's called mutating admission webhook. So whenever you create the cluster, a particular webhook is deployed in the cluster. So Kubernetes has this concept of admission webhook. There are two types: a validating admission webhook and the mutating. So validating example would be something called OPA, or open policy agent, wherein it allows you to set certain rules in the cluster, and those rules would always be evaluated, and based on that, let's say you are creating a deployment and you want that everybody should have a particular label called team is equal to my team, and if somebody is creating a deployment which doesn't have that label, it will just deny that. So it doesn't do anything to the existing deployment, but it sort of makes validates whether your deployment spec has anything. So what happens behind the scenes is that a pod runs, and you can run a pod wherein a service, and you make a call to that. What happens is so whenever someone is creating a deployment or a pod, the request to create that is intercepted by the admission webhook. In case of validating webhook, it just checks whether whether it's fine or not, and based on that, it makes a decision whether it's right or not, and denies whether you should go ahead and create the deployment or not. But In mutating, you can actually update your pod spec or your deployment spec, and add things like you can probably add the label as well. And that is the sort of thing that you do here in AWS does here. So it runs a pod int webhook inside of your cluster. The actual service or the pod actually runs on the control plane. So what you can do is you can just see. Okay, let me go back. You can just see whether there's a mutating webhook configuration in the cluster, but you cannot see the actual pod running because that is on the control plane side. So if you open this configuration, you will find a URL, something called 127.0.1:443/mutate or something. So that is the actual thing which is running on the control plane, which actually uh, which intercepts your requests, because your mutating webhook, admission webhook has been registered with the cluster, and it updates your pod spec and it adds those credentials into the cluster. Okay, now let's see. So the name of the webhook would be pod int webhook, and the code for this is actually open source. You can see it in the GitHub. There's a repo called EKS web int webhook. Okay. Now, what this webhook does is it adds certain environment variables to your pod. So whenever, let's say you are having a deployment, and in the deployment has uh, wherein you have added to the deployment a service account, and the service account has this annotation that we discussed about, that eks.amazonaws.com/ the role, and the value that we are talking about, the role ARN. So what it does is the webhook is it intercepts pod creation, and for every pod it's going to add certain variables. So for example, these 4 variables are there. One is AWS default region, then there's AWS region, then the role that you have configured in the service account. So you know that, okay, in your service account you added this role, and that will be available here. So all these variables are actually used by your assume role with web anti API, which is probably that you are using inside your AWS CLI or AWS SDK, be it Python or Boot SDK or any other JavaScript SDK. Then it also adds a token file, and this is your actual AWS credentials. So whenever your web anti API makes a request, it actually uses a token from here and gets those credentials, and interact with the AWS, and it has all the permissions that you defined in the AWS, in the service account as part of annotation. Now, apart from this, pod int webhook also adds several project, the volumes and volume mounts. So volumes are something, it's a AWS, it's a Kubernetes concept wherein you could mount anything, any file system or any persistence volume, right? And one of the concept is also a projected volume, and that is where we are using, that is what AWS mounts to your pod, and that provides you these credentials. If you see, you can probably see the the mount path is there. That is where the credentials come in, and they are actually coming in from this volume. And here we will have expiration second, so your credentials will automatically refresh after 86,400, that is right, seconds. Okay, apart from these annotation that I discussed about, one role ARN, there are other annotations are also supported by IRSA, so again by pod int webhook. And some of these are audience, STS regional endpoints, token expiration, and skip container. One disclaimer that STS regional endpoints is not working as of EKS 1.21. The audience is something, this is just a value which actually tells you what, which is relevant to the OIDC provider that you created as part of your cluster. And if you want to change it, there's a particular set of steps that you want to change it. It actually has no, I would say, no effect as such on anything. But if you want to, by default, it has a certain value. And if you want to change it, you actually have to go through a number of steps. If you want to actually change it and try it out, I have it written in my blog on how to do it, and what is the impact and what do you see. Okay, Apart from that, there's a token expiration annotation. You can use it to set by default the value for the token expiration is 86,400 seconds. You can change it to anything. You can change it to weeks or months. Again, one important annotation that I like particularly is skip containers. This is very useful whenever you have sidecar containers running in your cluster. For example, let's say you are using Istio, so you would have another sidecar container, or in case of Fargate, you could probably, instead of daemon set, you could use a sidecar container for X-ray. Amazon is AWS X-ray. So now you wouldn't want to have those containers to have these credentials, right? Because you just want it for your main container. Why would you want it for the rest of the container? So that is where you can define the skip containers to skip the other containers, because a pod can have multiple containers, right? But it should always be the best practice to use one-to-one container. There are other there are other some generalized practices around how to, if you should have multiple containers, but usually there's always one-to-one mapping. So that's where skip container comes into picture. One thing to note here, that skip container is actually a pod level annotation. It doesn't work on the service account. So until this point, we were setting all those annotations were on the service account, but skip containers actually only works on the pod level. Now, yeah, so if you want to do further reading on this, I've written a couple of blogs. You will get all the information about it in EKSIM deep dive that I've written on my personal blog. Apart from this, as I mentioned in the starting, there's another part that is EKS, a user accessing EKS and how the permissions and all work. I have written a very deep dive blog on that as well. I'll just send the link to it onto the
yeah
chat.
You can share it on the chat. Maybe you can share it as well on our Facebook group as well for the guys who didn't attend. That's great, Shardul. Is there any question, guys? Hit him some hard questions about Kubernetes and IAM. Salam is laughing. Looks like he has a good question. Any question, guys? You can just unmute yourself and ask directly.
I'll need to learn a lot to ask this kind of questions.
Sorry, what's that?
I'll need to learn a lot before asking this kind of questions.
Okay, so you have one question. Are these features available in a hyper deployment?
EKS anywhere, yeah, definitely. But that's where you have to actually deploy this identity webhook yourself. So as I said, right, it's an open source repo and it's on AWS Labs. I can probably give you the link as well. So it's called AWS EKS Web Identity Webhook, and you can deploy it. It has all the configuration that I talked about. All the documentation is right there in the review, so you can read it and you can do it yourself.
Awesome. Hope that answered your question, Ken. One more question, guys, before. Okay, Ken is happy with the answer. Okay, let's. Oh, I thought it's a new question. Okay, so that's it then. Don't forget, guys, just follow Shardul on LinkedIn, and he shares some cool link to his blog post, and hit him some questions if you want to know more later after this meetup. Hopefully, he will answer you for free. So before we end up this meetup, guys, do please give us a feedback. Did you like the session today? Do you have any feedback for our speakers as well? The speakers giving to the community, so we want to give them some feedback as well. So I will leave this QR code. Just do scan it, and please do fill it up. It will take like a few minutes only. And the last thing, don't forget to follow us on all social media pages and channels. So now we have a YouTube channel getting bigger, and Facebook is our main place where we have discussions, and Meetup where we share all the Meetups events that we have. We have a LinkedIn a group that Kaushik created, but we are still not active there. So maybe if you want to be more active on LinkedIn, you can join this group as well. So that's it, guys, for today. I want to thank Salam and Koshek. Salam, who's doing all this live streaming for the past 2 years, I think, 3 years now, when we used to do it at iFlex office. And Koshek is helping us as well in the community, bringing new speakers. So do thanks them on the chat. Okay, that's it, guys, and see you next month in October. Again, if you have anything you want to share, do reach out to us on Facebook, and we will arrange with you when is your turn that you can give a talk. So see you around, guys.
Thank you.
Thanks, Shardul. Thanks, man.
Thank you, Shardul. Really good. Thank you, everyone. All right. Salam, maybe you can go offline as well on YouTube.